Hi, welcome to today's video. This is a continuation of the C# beginner series. In our last video, we saw Visual Studio being installed, and I believe we have all been able to do that. In case you don't have Visual Studio installed, I do encourage you to watch the previous video before continuing with this video. So, today we will be looking at what data types are. So, what exactly are data types? Data types help to define the type of data that can be stored. They specify the size, the range, and the behavior of values which are stored. Now, why this is like this is because we have limited resources within our system. Our systems are not unlimited. For example, you might have a system of 500 gig, so it is limited to 500 gigabytes of data. So we need to find a way where we can allocate a particular size, for a particular range of data. So that is why we have data types. Now in C#, we have inbuilt data types. These inbuilt data types come with C# by default, out of the box. So you as a developer don't need to do anything to have this. So the first there is integers, we have the float, we have the double, the decimal, the boolean, the character, and the string. And we'll be going through each of them one after the other. So the first of them is the integers. So what are the integers? The integer data type is used to represent whole numbers without any fractional or decimal parts. It is important to note that, because when we speak of integers, decimals, anything that has to do with decimal points is ignored. It is a fundamental type that allows for efficient storage and manipulation of numerical values. The integer type in C# can be further categorized based on its size and signedness. When we say signedness, we mean if it allows negative values or not. So it includes the bytes, and we'll look at all of those: the long, we have the int, we have the short. So each variant has a specified range of values it can hold. Integers are commonly used for counting, indexing, and performing arithmetic operations in C#. And you must also know that the default value for integer data type is 0. So when we have a data type that is of integer, it always defaults to 0. That is, if no value is given to the integer, it defaults to 0. That's very important to note. So back to the subtypes. We have these subtypes. We have the byte, the signed byte, the short, the unsigned short, the int, the unsigned int, the long, and the unsigned long. And the bit sizes, we can see them. Now what I want to show us is the implication of this in our code. So I will go right away, and let's start with the bytes. So let's make this a little bigger. So let me just make this and make it 150%. Okay, so let's start with the byte. We have the byte, and we know that the byte is from the range of 0 to 255. So if I give it any value between that, we see that it has no problem with that. But when I come and I try to give it a value bigger than 255, you see it begins to give this error. That is because a byte is supposed to only have data between 0 to 257, sorry. So but if this was an unsigned byte, an unsigned byte, a short byte, a signed byte, that one expects -128 to 127. So for example, if I give this 54, it's fine with it. But if I give it 154, it will complain because it's above the threshold, which is 127. So that is for the signed byte and the byte. So let me just make this a byte so that the error goes. We also have the short, where we have a short is between -32,000 to +32,000. The exact values, let's go. As we can see here, the short is -32,768 to +32,767. So if I try to give it any value above 32,767, 32,767, right? So if I try to give it something like this, it will reject it because this is above the threshold. This is the limit it has. So for short, this is the limit. But if it was to be an unsigned short, for example, an unsigned short can definitely take more than this. It can take up to 65,000 thereabouts. So 65, you see, an unsigned short can take it. So what these data types, what they do is to specify the size. You know, when we were defining data type, we say it's going to determine the size. So for example, the size this can take is from 0 to 6 for an unsigned short is from 0 to 65,565, I think. 535. That is for an unsigned. So if I need a value bigger than that, so I could go to an integer, int, and let's call it enter. So and this could be anything. You can take values as big as this. The limit is let's check it. I think it's 2 billion. Yes, for an int it is from negative 2 billion to positive 2 billion. The exact values are here, but for an unsigned int you can take up to 4 million. So what this means is that for us, if we go back to our the code here, we see that for an integer this is not up to 2 billion, so it takes it. But if I put in a value bigger than 2 billion, so 3, so definitely this is 4 billion, so it's more than what an int can take. So we now have a long. So if I change this to a long, we see that a long can take this because a long is 64 bits and can take up to, let's check that, can take up to 18, I think this trillion, I'm not sure, for an unsigned, and for a long it's 9. So I think 9 trillion thereabouts is what that gets for us. So that is for the integer data types. So if we go to the float, double, and decimal, we see that these data types can be used when we have decimal points. Unlike in the integer data types, you know, we say that these are used for numbers without any fraction or decimal point. So even if it has a fraction or decimal point, it cuts it off for an integer. But when we need the decimal points, then we will come to the float, the double, or the decimal. So for example, if I'm just needing small decimal places, I could use the float, because as you can see, the float is 32 bits, the double is 64 bits, and the decimal is 128 bits. So why do we have 3 of them if at the end of the day all of them are decimal? The float is not very precise. It's the least precise among all of them. Double is a little bit more precise than the float, but decimal is very, very precise. So let's look at an example and see why I say so. So permit me to just type this and I'll come back to us. Alright, so this is basically it. And basically this console.write, what it means is that you want it to display whatever is here. So don't worry about what this means. In the future we'll look at what all of this means. But for now, let's just say this is what we are. Basically what I'm saying is that I want you to display the decimal up to 20 decimal places. That's basically what this means. So for a float, we use F to symbolize the float. So our compiler knows that this is a float. When we see the D, it knows this is a double, and M tells it that this is a decimal. So M tells it is decimal, D tells it is double, and F tells it it's a float. So if we run this now, we will see what we have here. So as we can see here, we see the first one here is for the float. When you look at it, you see the precision. You see by the time it's getting to the 8 or 9 decimal place, you find that it's no more correct. When you look at the next, you know, the next was for the double. You see it is more precise, but at some point it loses its precision at about the 15, 16 decimal place. And the last one here is the double, is the decimal. You see it is very, very precise. Even to the 20th decimal place, it's still showing 2 and 0.2. If I come here and I make this even up to, I say let it go all the way to 40 decimal place, and let's see how that comes out. we still see that even to 40 decimal places, it is still very, very precise. So this is why we have the decimal place. So the decimal data type is very, very useful for financial applications especially. So because for financial details that require high precision, when we are in need of a very, very precise data, we use the decimal. But it has a cost. The cost is that it is taking a larger space. So as we saw here, that the range for decimal is 128 bits. So it allocates 128 bits, unlike the float that just takes 32 bits. So for the 32 bits, it just gets a rough value, but not very precise. So when you don't need very high precision, when you are not very keen about precision, then we could use the float. The double is maybe a larger value, but we are also not keen about precision also. But when we are very keen about precision, we have to use the decimal data type. Here we see that these data types have their own specific uses, and your use case will determine which you should use. When you need high precision decimal values, then you will use the decimal. But when you don't need high precision, then you could use either the float or the double, depending on what circumstance. So if the value is greater than 10 raised to the power 38, of course it means you have to use the float in that situation. But when you need high precision, you always go for the double. Hope we get this clearly. If you have any questions, please drop it in the comment section. Please like, share, and subscribe, and see you in the next video.